Hello! Today we are going to solve exponential equations. We are going to solve two different types. First one, here I'm going to use this idea. Imagine that I have a power like this that equals another power with the same base. If this equals this and the bases are the same, obviously the exponents must be the same as well. So keep this idea in your mind and it will help you with these kind of equations. Look, here I have a power of base 2. If I had another power of base 2 here, I could apply this idea. So let's do it. It's easy to see that 8 equals 2 cubed. So to make it as a power of base 2, I have to make the exponent negative. And now I can equalize the exponents, as we said before. And let's work on this equation, second degree equation. We can move this to this side, adding, and this one adding to 1 plus 3 equals 4. So x equals square root of 4, which has two solutions, positive and negative 2. These are the values for x that I was looking for. Okay, now let's move to the next equation. In this case, we cannot apply this idea. This is a different type of exponential equation. So we have to work on this in a different way. Let's do it. I have to use properties of powers. Remember, when I had powers of the same base multiplying, I added the exponent. So in this case, I can write that this equals this. All right, because I use the property in the other direction, right? Powers of the same base multiplying, I have to add the exponent, so this is the same than this. Then I copy this, and I'm going to use as the similar property, but when we subtract the exponents. This comes from a division, 3 to the power of 1, right? Equals 76. Now I'm going to try to get rid of this denominator, so I can find a common denominator for the whole equations or in this case, since I have only these 3, I multiply the whole equation by 3. So this is 9. 9 times 3 would be 27 times 3 to the power of 2x minus 6, I multiply by 3, plus 3 to the power of x equals 3 times 76, that equals 228. Right, now let's operate with these two together because they are similar, right? So I can write that this is 27 times 3 to the power of 2x, negative 6, 3x plus 1, 3 to the power of x equals negative 5 times 3 to the power of x. And this is 228. Now we are going to change the variable and we are going to call 3 to the power of x, let's call it a. We are going to rewrite our equation now and we would have 27. This is like 3 to the power of x squared, right? Because this is the same than this. So in this case, I can write that this is 27a squared because this is a and square. And this is the same than this, remember. Then minus 5a equals 228. This is a second degree equation. I'll write it like this. This comes here subtracting. And now we are going to use our second degree formula to solve second degree equations, and we would have negative b, that is 5, plus or minus square root of b squared, that is 25, minus 4ac. A negative times a negative is a positive, and if we multiply 4 times 27 times 228, the result is 24,624. all over 2a, that is 2 times 27, that equals 54. Okay, if we perform this with our calculator, we obtain that the square root of this equals 157 over 54. So we obtain two solutions. Using the 5 plus 157, we obtain as a solution 3. And using minus 157, we obtain negative 76 over 27. Now we have to undo our change of variable, right? So we said that 3 to the power of x equals 8. Now we are going to place these values of a's here. So with the first solution, 3 to the power of x equals 3. I have powers of the same base. This is like 1. So my solution would be x equals 1. Now let's use this one. It would be 3 to the power of x equals negative 76 over 27. If I raise 3 to any exponent, it could be positive, negative, any real number. I would never obtain a negative result. So with this value for a, I don't obtain another solution. I don't obtain any solutions with this. So the only solution would be x equals 1. I hope you understood. Bye. See you soon.